Hi children, today let us discuss about the force on a charged particle in a magnetic field. Just like a charged particle experiences an electric force F is equal to Q into E in an electric field, it experiences a magnetic force F is equal to Q into V cross B in a magnetic field. In the first chapter, we have studied that if we keep a charge in an electric field, it will experience an electric force Q into E. Similarly, if we keep a charged particle in a magnetic field B, it will experience a magnetic force given by FB, vector FB, equal to Q into vector V cross vector B, where Q is the charge of the charged particle, V is the velocity of the charged particle, and B is the magnetic field. Or we can expand the equation like FB is equal to Q into VB sin theta, because you know vector A cross vector B equal to AB sin theta. Therefore, the magnitude of magnetic force we can write FB equal to QVB sin theta. This equation will give you the magnitude of the magnetic force. So, I will repeat the magnetic force on a charged particle vector FB equal to Q into vector V cross vector B, or magnitude is FB is equal to QVB sin theta. Here theta is angle between V and B, that is velocity and a magnetic field. Let us consider three cases. First, when theta is equal to 90 degree. When theta is equal to 90 degree, sin 90 is equal to 1, and we will get F is equal to QVB into 1 equal to QVB. That is, the charged particle will experience maximum force, because sin theta is having maximum value of 1. The maximum value of magnetic force will be QVB, and it is when the charged particle is moving perpendicular to the magnetic field when theta is equal to 90 degree. When the angle between velocity and a magnetic field is 90 degree, that is when the charged particle is moving perpendicular to the magnetic field, the magnetic force will be maximum and its value is given as Q into V into B. Second case is when theta is equal to 0. Theta is equal to 0 means velocity and magnetic field both are in the same direction. Both are parallel. That is, if the charged particle moves in the same direction as that of magnetic field, then putting theta is equal to 0, sin theta is equal to 0, therefore we will get F is equal to Q into V into B into 0, that is 0. That is, force will be 0. There will be no force. No force means it will continue its motion having no change. From Newton's second law, we know a force will produce acceleration F is equal to ma. If force is equal to 0, there is no acceleration. It will continue the same motion. Therefore, if theta is equal to 0, that is, if the charged particle is moving in the direction of magnetic field, it will continue its motion without changing its velocity, without deviating from its path. It will continue its same motion. And next case is when theta is equal to 180 degree. 180 degree means if the charged particle moves in the opposite direction of the magnetic field. If the angle between velocity and a magnetic field is 180 degree, that is if they are anti-parallel, not parallel, anti-parallel. Again, sin 180 is equal to 0. Therefore, we will get force F is equal to QVB sin 180 equal to 0. In this case also, there will be no magnetic force acting on the charged particle. Therefore, there will be no change in the velocity of the charged particle, no change in the motion of the charged particle. It will continue the same motion. So, let us take a recap. We know the magnetic force F is equal to vector F is equal to Q into vector V cross vector B, and its magnitude is given as Fb equal to QVB sin theta. Let us consider three cases. First case, when the angle between velocity and a magnetic field is 90 degree. In this case, force is maximum. Magnetic force on the charged particle is maximum because sin 90 is equal to 1. We will get magnetic force F is equal to Q into V into B. In the second case, theta is equal to 0 degree. That is, the charged particle is moving in the same direction as that of magnetic field. We will get sin 0 is equal to 0. Therefore, magnetic force F will be 0. Therefore, the charged particle will move without any change in the motion. And the last case is theta is equal to 180 degree. That is when the charged particle moves in the opposite direction of the magnetic field. In this case, sin 180 is equal to 0. Therefore, the magnetic force F will be 0 again. In this case also, the charged particle will move without any change in its motion. Now, from the equation of magnetic force Fb is equal to QVB sin theta, we can say the force depends on Q, V and B. That is charge of the particle, velocity of the particle and a magnetic field. And force on a negative charge is opposite to that on a positive charge. We can write magnetic force on a negative charge is equal to minus Q. For negative charge, the sign is minus vector V cross vector B. So, here we can see the direction of magnetic force for a negative charge will be opposite to the direction of magnetic force for a positive charge. Next, the magnetic force includes a vector product of velocity and a magnetic field, that is V cross B. The vector product makes the force due to magnetic field vanish, which means become 0 if velocity and a magnetic field are parallel or anti-parallel. This one we already discussed. And the third point is the magnetic force is 0 if charge is not moving. That is when velocity is equal to 0. Only a moving charge feels the magnetic force. This one also we can find from the equation F is equal to QVB sin theta. If velocity is equal to 0, the magnetic force will be 0. Therefore, the magnetic force on a charge at a rest will be 0. A charge will experience magnetic force in a magnetic field only if it's moving. From the equation of magnetic force Fb is equal to QVB sin theta, we can define 1 Tesla. You know, Tesla is the unit of magnetic field, and we can define 1 Tesla from the equation F is equal to QVB sin theta. If you put Q is equal to 1 coulomb, V is equal to 1 meter per second and B is equal to 1 Tesla, you will get F is equal to 1 Newton. Therefore, we can define Tesla as the magnitude of magnetic field B is 1 Tesla when the force acting on a unit charge, that is 1 coulomb, moving perpendicular to B with a speed 1 meter per second is 1 Newton. Next, let us find the direction of the magnetic force using screw rule or right hand rule for vector product. In the first year, we have studied the screw rule for vector product. The same rule we can use to find the direction of magnetic force.